Let us start this particular session on project management, and very important topic under the project management is project design and network analysis. Basically, we talk about the project design. Project design as a heart of the particular project management. Any project, you'll understand that this particular topic, project design, and obviously the concern related to techniques which we will be discussing today in terms of CPM and PERT. So these two techniques are very much utilized and very much used, and this project design is a very crucial part of any particular project management. When we start this project designing, then after that feasibility analysis, this become very important to uh, put the activities on paper, black and white, and chalk down on the paper that what route would be good for this particular project, which activity should be keep in the project, and which activity should be kept out of the project. So in that case, these two methods, which are very common, very prominent, and they are very crucial. Let us start this particular project design and network analysis. And today's session we will discuss about the critical path method only, CPM, and in the next continuing session we will focus on PERT. This project design would be splitted in two lectures. I have tried to change little bit in-depth material in this particular topic, and that is why I am taking two lectures on this. I'll try to take examples also to make you learn about the critical path method, and it will be better if you just keep a rough notebook aside and keep noted down whatever I am giving you as example or numerical. So it will be very helpful to you. So okay, when we talk about that critical path method and this PERT, we must understand some historical background. Critical path method, this particular technique was first time innovated by EI DuPont de Nemours company. This company was involved in construction of chemical plants, and they invented this particular technique. First time they used this particular technique to understand that what are the different activities to be performed in new plant establishment and maintenance. Why? Because in case of maintenance, you are not you are indirectly affecting the ongoing process of plant. So to minimize, to optimize, these methods are also called as optimization techniques for important optimization techniques for engineers. So whenever you talk about engineering line, be it anyone, so activities of systematic activities and then choosing the right track, right route, critical path, what we talk about, that is very important. But you must understand whether you should your case or your the project is very fit for critical path method or PERT. We will discuss in this these two sessions. Critical path method is basically based on the deterministic task time. Say for example, we say that one activity is there to go from west campus to east campus, right? So the starting point of this activity is west campus, and the end point is east campus, and this activity is a deterministic task time. You can say that it takes 5 minutes. If this thing is very much determined, then you can go for critical path method. If you do not have this going from west campus to east campus takes 5 minutes is not determined, you are about to project, you are about to calculate on the probabilistic model. That means from going west campus to east campus, it may take 10 minutes maximum, it may take minimum 5 minutes, and on an average it takes 7 minutes. So you are not having determined time, you are having probability of happening event, probability of occurring activity. So when you have the probabilistic time, that means you are not sure about the exact determined time of the activity, then you can go for PERT method. If you do have fixed, exactly known time duration of the activity, you can go with the critical path method. So we talk about that. It is basically deterministic model of optimization. Critical path method is deterministic model of optimization. It is the network design is basically based on activity on nodes. We will discuss about the node, slack, leeway. These are some terminologies which we will discuss in today's lecture. It is basically repetitive nature of job, means one activity may be repeated with the second activity. When we will design the particular particular path network, then you can understand this concept. When we talk about that project evaluation and review technique, then we are very much concerned about that this particular technique was also invented during the same period but by US Navy for their missile program. Critical path method was first time invented in 1957, whereas the PERT was invented in 1958, just after 1 year. And this was basically for missile program, because that program was the activities associated with the any missile program, they are not having deterministic time slot. You cannot determine, you can only say that maximum, minimum, average, like this, because it is future activity. So whenever you are giving future activity, and whenever you have repetitive nature of job and you are taking, you know that this must take exactly this time, then you can go for path method, CPM. Probabilistic nature is very clear. Activity on arrow we will discuss in when discuss about PERT. It is non-repetitive jobs. Say for example, in missile programs, once one activity is performed, so it cannot be repeated to check how much time it took. So to ensure this, you must go with the probabilistic model. This one is called as a probabilistic optimization technique. So what is critical path method and PERT? These both are used as the optimization techniques, network based techniques. First, the activities are network is designed, and this network is designed to assist in the planning, scheduling and control of the projects. This is a very important issue. When you want to plan any particular project, when you have to schedule, you know activities, you know the time duration, and you want to schedule it, and obviously this helps you in controlling the projects, controlling the activities. A project is a collection of interrelated activities, as we have discussed, with each activity consuming time and resources. Time means it has a start time and end time. The objective of CPM and PERT is to provide analytical means of scheduling the activities, because when you are supposed to start any particular new business, so you must have the first activity. Say for example, you say first activity you are going for incubation, prototyping, and prototyping requires 3 months. Now in this one, it is not repetitive in nature. So when you go for prototyping, it is not repetitive in nature. So obviously you will say that prototyping may take maximum 3 months. Prototyping may take minimum 1 month, the best possible time, and the optimum time. So you use PERT method to schedule those activities of this prototyping, because it is non-repetitive type of job. So what exactly these two techniques are supposed for different purposes, since these two techniques were independently developed. Actually they differs in form of deterministic activity duration and probabilistic duration. We have discussed these things. Now we'll start CPM first in today's lecture and followed by PERT in next continuing lecture. Network representation. When you are given that first activity is to go from west campus to east campus, second activity is to move to your classroom, third activity is to open your bag, fourth activity is to start your taking class. So these activities are in sequence. Now how to schedule it? If you want to schedule it, obviously you make a network diagram. So we'll take example to explain you, but first the basic fundamentals of how to develop a network, how to design network. You must understand two things in project design. In project design, one thing is very important, that network design, and another thing is network analysis. Network design is equally important as network analysis, but if you do mistake in network designing, then your analysis would be wrong and your project will have a problem. And that is why I say, while you design the particular network, you must be very careful while designing the network. And that is why I have taken this critical path method, which also includes network designing. Main focus is on network designing, then we will take network analysis also. So we'll try to give you very in-depth knowledge about the network design. So what exactly it means, that each activity in network is of a project is represented by an arc pointing in the direction of the progress in the project. The node of the network establishes the precedence relationship amongst the different activities of the project. Means there are two nodes of any activity, starting node and end node. So these starting and end node is basically the connecting nodes of one activity to another activity. There are two rules which are very clear in constructing the network. First, each activity is represented by one and only one arc. You cannot have more than one arc to represent activity. Each activity must be identified by two distinct end nodes. Look at this. A is an activity, one is starting node and two is end node. This thing is very clear. So you must understand that when you design an activity, now look at the example we took, that if A activity is moving from west campus to east campus, so starting activity 1 is west campus and 2 is east campus, and how much time it takes from moving west campus 1 to 2 is an activity, and it consumes 5 minutes if deterministic time. If probabilistic time, it may be different. That will be discussed in PERT. What is the dummy activity? Dummy activity is just to correct the precedence relationship. Dummy activity is used. A dummy activity, which is normally depicted by the dashed arc, consumes no time or resources. That means dummy activity is not using any time or resource. So if there is a zero thing, so you can understand, you can look at that this is the dummy activity. We will discuss in designing network. If two activities can start concurrently and have the same duration, can be represented using a dummy activity as, look at this. Now A is an activity and B is an activity, and A activity and B activity are ending at node 2, right? So A activity is 1 to 2, B activity is 3 to 2, or you can say and this A to this activity 1 to 3 is considered as a dummy activity because it does not have any time or duration. They're starting at the same time. It may be in this form also. 1 to 2, 1 to 2 A activity, 1 to 3 B activity. If they are not, they are starting from same node. In previous example, we had taken that the two activities are ending at same node. But in this activity, in this example, I am taking that two activities are originating start from same node and ending at different nodes. So A is one activity 1 to 2, B is another activity 1 to 3, and 3 to 2 or 2 to 3 is basically a dummy activity. So this one is a dummy activity. So just to explain it in detail, I'm just taking this example. Rule 3 is to maintain the correct precedence relationship, the following questions must be answered as each activity is added to network. Whenever you go that, okay, A activity, when you want to add B activity to A, you must ask what activity must immediately precede the current activity. That means what is the next activity after that. Another question, what activity must follow the concurrent activity? That means whether B is following A or B is not following A. B is independent or not independent. B is having a starting node as same as the end node of any particular activity or not. And what activities must occur concurrently with the current activities, means parallel. If there are some parallel activities to be depicted in network, you must look into that. To answer these questions may require the use of dummy activities. Sometime you need it. Now let us test this particular example. If you have your pen and paper along with you, I can just give you through this example. I'll try to take two examples I have included in my lecture. You can note it down that how to construct a network design a network with this example. It is just like a question. A activity is fixed deterministic time period is critical path method problem. It takes suppose 8 minutes, and this activity is starting from 0, means it does not proceed after any activity. So origin point. B is again starting from 0. C is again starting from 0. No precedence. So that means before C, no activity. Before B, no activity. Before A, no activity. That means all these A, B, C, 3 activities are, and these 3 activities are taking 8 minutes, 8 minutes, 9 minutes. D activity is taking 3 minutes, and the precedence is that D activity starts after A. That means this is very clear. That means the starting node of D, look at this, starting node of D would be same as the end node of A, and this comes from this information. Look at this, like E is taking 6 minutes and E is proceeding after B, means the end node of B would be starting node of E. Look at very clearly. So when you design diagram, it will be very clear. And likewise C, that means this F activity is starting after C and connecting to C. G activity is basically taking 7 minutes and starting after D, E, F. Are you getting my point? That means the D activity and E activity and F activity, these three activity would be having same end node as G, same end node, and G's starting node. H activity is starting after C, and the I activity is the 0 activity, 0 minutes, and which follows G and H. So we will take just to change this. Look at this. Now since I activity is 0, so it is just an diagram will depict there. And look at this, problem can be changed into this format as we have discussed in previous slide. A activity, suppose A activity starts from one node, node 1, and ends at second node. B activity starts from one node, ends at third node. C activity starts from one node and ends at, and time duration is 6. So these activities are defined along with the nodes. Now the problem is this particular thing is added into this problem. Now this is very crucial to design. Once you have done it, then it becomes easy to make a network diagram. D activity is having same starting node as the end node of A. Look at this. So it starts from node 2 and end at node 5. It's very clear. E starts from node 3 because it is preceding B. So end node is 3. So starting node is 3 and 5. Why this 5? This thing is very important. Because D, look at this G. D, E, F is ending at G. So end node is common. So end node of all these three would be common, 5. So 3 to 5, 4 to 5, and it takes this much. Now when we design the network on paper, we must look at that scaling of this. If we will make A activity, look at, so we should make it 8 centimeter, B 8 centimeter, C 9 centimeter, D 3 centimeter, E 6 centimeter, F 2 centimeter, approximately. I am not saying that exactly you make centimeter, minute and centimeter, but so that network become most probably the because network is depicted in your mind, so you can very easily understand that yes, F activity is very short activity. So by just network you can understand. And this 6, now look at this, H activity follows C, and C end node 4, so 4 to 6. So let us start making this particular problem. So when you design network, look at first activity. This is, we look at that A and B activities are there, and there is a C activity, right? So even though in picture I tried to differentiate, but anyhow 8 minutes and 9 minutes, this should be a little bit shorter. So okay, you can keep a concern on it. Then there is a D activity followed by A. So D is basically 2 to 5. Look at your second problem modification. So likewise E and likewise F. And then there is a G activity which is 5 to 6, and H activity is 4 to 6, as we had taken in your second problem. So once you define that nodes of an activity, then it becomes very easy to make network diagram, right? Now what critical path method means? Critical path method means, if you look at, you will find that a project starts from node 1 and it ends at 6, node 6. You can understand that ith activity was defined as 0. That means this is at 6 itself. So you can look at that if you make 6 activity, there is no activity because there is no 0. So you can take dummy. So you can make dash, 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 dash. And you can say I. So this is starting of your project and this is your end of your project, 6th node, right? Now to reach 6 point, you have this route path, right? Another route is this, you directly move like this. Another route is you can move like this. There is a fourth way that you can move like this. So it is just like that to reach to east campus from west campus. You have different route. You can go via Chidiaghar. You can go via Gurudev and Rawatpur, and you can also go via directly to Ganga Barrage and then moving to Raina Market and then coming back. Now, which route is optimum? Which route gives you technically, which will save your time? What is the critical path? So you can with this method you can very easily understand, because it is given that yes, A activity takes 8 minutes, B activity takes 8 minutes, C activity takes 9 minutes. Okay. So we'll discuss this in my lecture. Second example that I am taking is that if you have to construct a network consisting the activities from A to I with the following precedence relationship. Now the question is given in a different format. Look at. Question is given in a different format. Question says that the precedence is given that A and B activity, the first activities of the project starts immediately, right? Parallelly, A at the same time. Now A and B precedes C. B precedes D and E. A and B precedes F activity. F and D precedes G and H activity, and C and G precedes I activity. E, H, I are the terminal activities, that means terminated activities. Now this problem is a little bit complicated problem. Now how to start with it? Look at, we will try to make the network diagram with this. Starting from first, you have one activity A 1 to 2, right? B 1 to 3, because they are starting activities, that means their start node is same and their end node is different. That means for A activity end node is 2, for B activity end node is 3, right? Second, you can say that this one is a dummy activity, 3 to 2. Now this C is following A, so you can understand that 2 to 4. This D is following B, and this is also following just a minute, there is some thing. Now this is another issue of just a minute, some system is hanging. So now how to compute critical path? This become very important to understand that you must look at the time schedule for the activities, each activity. You must have deterministic time for each activity, Total duration needed to complete the project must be calculated. The classification of the activities of projects as critical and non-critical. Now look at, critical activities are those activities which falls on the right, correct path, and non-critical activities, how to understand that some activity is non-critical, we will discuss in next few slides. An activity is said to be critical if there is a no leeway in determining its start and finish time. Say for example, if an A activity is starting from first and finishing at second point, and on second node there is a different D activity which is starting. Now the starting time of, earliest starting time of node 2, that means D activity, and earliest finish time, latest finish time of A activity, because once A activity is finished then only D activity can start. Now if that node 2 is a terminating point of more than 2 activities, so you must understand that as earliest when you can start this D activity and the latest when you can start this D activity. If there is a gap, that means earliest start time and latest completion time, if they are not same, then that activity would be called as a non-critical activities and there is a leeway. That is called as a, there's some non-critical activities allow some scheduling slack. There is some slack into their earliest start time and latest finish time. So the start time of the activity can be delayed or advanced within limits without affecting the total completion time. To carry out the necessary computation, we define an event as a point in time at which some activities are terminated and others started. Look at this. Suppose event J is there. J means J is considered as a node, right? So we define earliest start time at node J with this, say for example square J, and on network it will be depicted as a square. So it is an earliest start and occurrence time of the event J. On event J and which is starting at J node. Latest completion time or occurrence time of the event J is depicted usually with a triangle. These are some standard you will find in most of the books, that triangle represents the latest completion time and the square represents the earliest start time, and D is usually duration of the activity. Ij means from ith node to jth node, so like 1 to 2 node. The definition of the earliest and latest occurrence times of the event J are specified relative to start and completion time of the projects. It is to be noted that the earliest occurrence time of the event J is the earliest time at which all the activities emanating from the node J can start, right? So earliest means if there are more than one activity ending at node J. So as earliest as possible, when you can start the jth activity, when the last end node finishes at jth. Similarly, the latest occurrence time of the event J is the latest time by which all activities that end at node J must be completed. So these things are very important. Two things are very important. Critical path calculation involves two passes. The forward pass determines the earliest occurrence times of the event. We will discuss, we will calculate that taking one example. And the backward pass time is calculated from the backward side, means If you move from first activity 1 node to 2, 3, 4, 5, 6, and you keep on calculating the forward pass time, right? Determine the earliest occurrence times. Then backward pass calculation is when you start from the last activity and calculate backward, and from 10th node you come back to first node. That is the latest occurrence time. Forward pass earliest occurrence, the computation starts at node 1 and advance recursively to the end node n. Initial step, we set ES1 as 0. This means that project starts at time 0. General step, next we go to that if jth node is there. So this P comma J, Q comma J or V comma J are the activities ending at the node J, same node ending, and we define it as ES I is equal to maximum ES plus DPI, ESQ plus TQI, and likewise. So we keep on adding the duration of next activity to the earliest start time, and the forward pass ends at ESN has been calculated, which is the duration of the project. Backward time computation now starts at the node n, last node, and advance recursively to the start node, reverse. So we say that LCN is equal to ESN. That means in forward, the total time taken at the last node n was considered as the LCN the first. Say for example, in forward calculation, you calculated all the earliest start time, and at the end it comes at 56 minutes. So 56 minutes for backward pass is considered as the initial first data, and then from 56 you will subtract the preceding before activity duration. General step is that you keep on subtracting the last, suppose 56 minutes, right? 56 minutes minus that activity duration. So that will give you the previous penultimate node, that latest finish time. So let us look at this. Based on this preceding calculation, the activities Ij is called critical if. Now we look at that if ES1, earliest start time, and latest completion time is same, so that activity is called as a critical activity. And usually earliest start, thus an activity I and J is critical if the earliest occurrence time and latest occurrence time of the time and its node are same, and their difference is the duration of the activity. So when you say that there is a difference, so there is a difference. Suppose this one is just ESI and ESZ, because it is I and Z. So ESZ minus ESI or LCZ minus LCI gives you the duration of the activity. So a critical path of the project, of a path comprising of the critical activities of the project, it is to be remembered that a project can have more than one critical path. It's there. Any critical path will start at node 1 and will end at the node n, and that the sum of the duration of the activities lying on that critical path is duration of the project. Look at this. This was the example that I had taken initially. We had designed this network initially, right? Now I have just depicted time duration of those 8 minutes, 8 minutes, 9 minutes, 6 minutes, 3 minutes, 2 minutes, 7 minutes, 6 minutes, if minute is considered as the unit of this duration. Okay, so let us start this calculating Earliest start time ES1 would be 0. Now earliest start time at 2, ES2 would be 8, and this comes with this 8, and this would be like this, and like this. Look at, this will be 8, this will be 9. Now if you look at this preceding, so you can understand that the 5 will maybe the 8, 3, 11. So we are not taking, because we take the maximum. So 8, 6 and this will be 14, and this 9 to 11. So earliest start time, the earliest you can start this activity, earliest would be this. Earliest means maximum, 14. So we put at 14. And then we say that yes, 14 plus 7 is equal to 21. Now this 21 is the project time. So this will also be LC6. LC6, latest completion time is 21 minutes. Now we start calculating the backward pass. 21 at this point, then minus, at this point it will be 14. It's clear. Now at this point, look at this 4. When you subtract 6 minutes from 21, it will give you 15, right? Now it will give you 15. This will be 8, this will be 11, this will be 0. Look at this. 14 minus 3, 11, 11 minus 8. So it is, since it is starting point, so 0, obviously. And in this one, this become very important. In this one, look at 14 minus 6, 8, and 8 minus 8, 0. This, look at 14 minus 2, you have 12. But since we are supposed to look at the, so we are supposed to look at that latest completion time of this activity in reverse case. So we take highest, so we put at a 15, not as a 12. And then we look at this activity also, that if you take 15 or you go by this one, so this will be always 0. Starting of the project and the end of the project will have same thing. Now you are supposed to look at the critical path. Which one is the critical path you should follow? So critical activities are those activities where the ES and LC are same. Look at this, and this is same. So one node is on critical path. This 2 node is not on critical path because ES1 is 11 and LC is 8. 3 is on critical path because 8, 8. 5 is on critical path because 14, 14, and this 21, 21. So we can understand that this is your critical activities and critical path, right? So this you can very easily understand that how to determine the critical path. You can understand that B, E and G activities. Project should follow B activity, E activity and G activity and other activities. By these activities you can get the optimum network and optimum time. Likewise, the second example that I had taken, that was this example, and this says that first activity was 2 minutes, 3 minutes. This was dummy activity and followed by this. And you know that the F and D activities were having same terminating end. So in this case, you can understand, you can calculate like this: 0, then you can say 3, 3. Why it is 3? Now this is very crucial question. Why 3? This is 3 because we take highest. Highest means this is in dummy activity. So you add 0 in this activity, so you will get here 3. And with this 3, when you add 4, you will get 7, because when you add 2 in this 3, you will get 5, and we need to take highest one. So 7, from this side you will get 7. Now on node 4, look at this. This 7 plus 6 give you 13. So we take 13. We are not taking 3 to add 5 and 8. Highest we take. And likewise, on this, we have, look at this. There is some something. This should be 4. So look at this. 13 plus 3, 16. But look at here. 7 plus 10, 17. So we take this highest 17 here. Now for calculating the reverse, we do take this 17. Now when minus, it will come 14. Minus 10, 7. 3. This will be 3. 0. Now look at the dummy path, because we had 3 was coming from this dummy root. So this is the critical path that is giving, in second example, that is giving you the earliest start time and the latest completion time as same. There is no slack. In this one there is a slack, and that is why we excluded this activity. So this is not coming on critical track path, and since it is not coming on critical track path, so it is non-critical activity. It is not critical activity. So we just tried to look into